Next, I'd like to show you some interesting things that you can do with the one proportion z-interval formula. You might remember that formula for the one proportion z-interval is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. And this formula has different parts. P hat is the estimate. Z star times this square root expression is the margin of error, which consists of two parts. Z star is the critical value, and this part, the square root of p hat times 1 minus p hat over n, is the standard error of p hat. Now, if you know the boundaries of a confidence interval and you know the level of confidence, you can figure out a lot about these other components that are in this formula right here. And that's what we're going to do next. Suppose you have a 95% confidence interval for P, your population proportion, and it has these boundaries, the left bound and the right bound. If you want to find P hat, the margin of error, Z star, the standard error of P hat, and n, you can do all that with just this limited these limited pieces of information. So here's how you do it. To find P hat, you just average the boundaries. So you add those two numbers together, divide by 2, there you go. P hat is 0.66 in this case. That's directly in the middle of this interval. Okay, and that's where P hat always is. It's directly in the middle. Okay, next, if you want to find the margin of error, you can do it two different ways. One way is to take the difference in the boundaries and divide by 2, and in this case you'll get 0.06565. That's the method I call splitting the difference. You can also do it by subtracting the right bound minus p hat, because the difference between the boundaries and the middle is the margin of error. So you could also do it that way, and I'll show you how that works. It's pretty simple. Okay, you just take 0.72565 minus 0.66. Okay, so the right boundary minus p hat. You get the same margin of error either way, as you must. Okay, if you want to find z star, well, you can look that up. If you know the level of confidence, just look that up in the little table that I gave you before. If you want to find the standard error of p hat, that is the margin of error divided by the z star. So you take the margin of error that we just calculated and the z star that we just found and divide. You get 0.0335 for that standard error. And then there's one other thing you can find, the sample size, n. And all you have to do is solve this equation. Okay, the standard error of p hat is something we now know. We know what p hat is. We can solve this equation for n because it's the only unknown left in the equation. Okay, so you plug in the things that you know, and then you solve. You can square both sides and then rearrange the equation. You get n equals 0.66 over 0.34 divided by 0.0335 squared, and that's approximately 200. Here's another example. Okay, suppose we have the confidence interval, 0.52 to 0.60, and the sample size is 417. With that information, we can figure out all of these things. The sample proportion p hat, the margin of error, the standard error of p hat, z star, and the level of confidence, c. Okay, to find p hat, again, average the boundaries, add them up, divide by 2, you get 0.56. To find the margin of error, take the right bound minus the value of p hat. To find the standard error of p hat, you can use this value of p hat from right here and the sample size that we were given and just plug them into the standard error formula. You get 0.0243. To find z star, just divide the margin of error right here by the standard error of p hat right there, and you get approximately 1.645. It's a little bit of rounding error in there, but that's all right. And for our z star of 1.645, the confidence level is 90%. So you can find all that stuff by just doing a little bit of work from that given information, using the formula, working backwards. Okay, so it's a nice little skill to have, to be able to work backwards from a confidence interval and some other information to find these other things, and it helps you to learn the formula as well. So give it a try.